Good, uh, good afternoon, everybody. My name is Andrea, and I'm from Keysight Laboratories, which is the research division of Keysight Technologies. And today I would like to introduce you to test as a service, the main concepts, but also provide you some useful tools that you can apply when designing your experiments and your use cases for your own project. Let's start from the agenda for today. First, build a vocabulary of what testing, monitoring, telemetry, and other useful concepts can apply to your case. Then I will provide you an overview of what is test as a service, what are the main principles, and then diving in on what test cases, test campaign, and experiments are in our own domain, and provide you also with some examples on how to build your own. Finally, some basic concepts of monitoring and some conclusions. But let's first start with building a common vocabulary. Let's start first from testing. What does testing mean? Well, testing means taking measures of quality, performance, reliability of your own network, slice, infrastructure, service, if you wish. And this is an active approach where we are actively stressing your system under test in order to provide the specific measures. Monitoring, on the other hand, it's a passive interaction where we are observing the system in order to verify progress or quality over a period of time. That applies to anything from a component to the traffic flowing through the network. Finally, telemetry applies specifically to components, and it is understanding through measurements the behavior of the individual components that compose your system. Now, let's now dig into what test as a service is. But before we start with test as a service, we need to understand why we need test as a service. I think we all know how a 5G network more or less looks like. It is very complex. There are so many new technologies that needs to be interconnected. Technologies that are not common in telecommunications, for example, clouds. There is a bridging with IT systems. And all these technologies, they need to interplay together. Each technology has a massive amount of possible configurations, and not all the configurations are useful to achieve the highest performance of the network. So what can possibly go wrong when we put everything together? Well, there are a lot of different things. In order to avoid these issues, what we can do is testing. Testing is a very challenging topic. Not everybody is used to this type of approach. For this reason, we wanted to make it easy for everybody to consume testing in a very simple and transparent fashion. As you can see, there are a lot of different test types at each of the levels and the components of the 5G network. For this reason, the task system is the one ring to rule them all. Make, make it accessible for everybody to do testing. This is, in particular, the vision that the 5G PPP test measurement and KPIs validation working group has defined. Let's have now an example on how to consume tasks, as it was also explained in the 5G-VINNI onboarding webinar. There are two ways of consuming a task system in terms of vision, either by a manual interaction of the user or with a programmatic test request from another system, being an orchestrator or a CI/CD pipeline. The task system, in particular the one that we are currently defining in 5G-VINNI, is able to take the request of which test type or campaign the user needs to execute, load it into a test orchestrator that is OpenTap, as you have also seen in this series of webinars, that can take care of controlling all the actors that are involved into the testing. Let's have now a look to what test cases, test campaign, and experiments mean. There are two different things that we need to take into account. And that's what the ICT Fireworks project did in the past. Testing has a known list of stimuli and observation points. And that's because we know how the system is supposed to behave, and we want to check if it is behaving correctly. On the other hand, being the vertical applications and the 5G networks so new, we don't have a clear understanding of what is the correct behavior. We have an idea, but we don't have a model. With experimentation, we want to find the right stimuli and the right observation points to assess the system, derive the behavioral model that we can later on use in testing. Now, where should we start? What is the starting point? Well, the starting point when we are talking about testing and experimentation is always the KPIs. We need to understand what we want to measure. And I am on purpose saying measure. I have often seen people, when asked about KPIs, to put a generic throughput out in the air and requesting a specific SLA associated. That comes much later. The first thing we need to understand is that we need to have a very clear understanding of what we can measure out of our system and how to process these measurements in a way that makes sense. The 5G PPP test measurement and KPIs validation working group has, for example, defined a basic set of core KPIs that can be used for testing. Please bear in mind that the KPIs for testing might be, and most of the times are, different from the KPIs that we want to monitor in a passive fashion. As an example, I cannot passively measure the peak throughput of a system, the maximum achievable throughput of a system, because the traffic load in the system might not be high enough. That's where the difference between testing and monitoring starts playing a role. Obviously, when we talk about testing, we need to associate an SLA value to each of the KPIs to understand if the test we are performing is passing or failing. When I say the test we are performing, I am referring to what is normally called a test case. A test case is a way to formalize and glue together all that is needed to coherently and reliably perform a test, starting from the initial conditions of the system, the test environment in which the test needs to be performed, what is the exact procedure or methodology that needs to be followed in the test, and which type of measurements and KPIs we are interested in collecting and stressing. This is a test case. Now, there are different elements characterizing the test cases and testing in general. We can start from at which stage of the system development or deployment we are performing the testing. That defines the phases. We can perform integration tests when we are gluing together different pieces. We can define acceptance test cases when the system needs to perform according to certain requirements, or regression tests that we are repeatedly performing in order to ensure that whatever we do with the system, the performance do not break. In a similar fashion, we can have different system on the tests. We can have, for example, unit tests. Let me provide a simple example. Imagine the user plane function of the 5G core network. We can test just that functionality, forgetting all the rest. That is my system on the test. Or I can take, for example, the AMF and the UPF as my system on the test. In that case is what it's called a subsystem. Or I can take an entire slice as my system on the test. In that case, it would be my service or system. But how can we perform the tests? Well, in the case of a UPF, what we need to do, we need to take the system on the test and wrap it around testing tools. That's what it's called, a wraparound test. Or we can perform end-to-end tests. If we have a slice as a system on the test, well then end-to-end tests is what we need to perform. In a similar fashion, we can define the test environments. Why is it important? It is important to understand in which conditions the system is currently running, to make sure that we are not biased, for example, by noisy neighbors. The IETF in the RFC 2544 starts defining certain types of what we call test environments. There are, for example, isolated test environments, or what's normally referred to as sandbox. A sandbox is a place where you can perform any type of tests without being disturbed by the outer world. For people who are more skilled in RF, you can imagine as a shielded box or a semi-isolated test environment where, for example, there is only a limited interaction with external environments, but we have shared resources. Imagine you have your own set of servers and you are running a couple of experiments at the same time. You cannot guarantee that one experiment is not even slightly or remotely affecting the other. That's what we called a semi-isolated test environment. As example, we can also take a test slice where we are only performing tests. Or we have non-isolated test environments. Imagine running your own experiments in a network where there are other customers running. In that case, we need to be aware that the test we are performing has a certain level of repeatability and reliability because it might depend on the current load of the network. There are also different types of tests depending on what we are trying to prove, what we are trying to verify. The most common and the most relatable of all is the performance test. A traditional ping or speed test that we freely do on the internet, it's a performance test. We want to see what is the operational speed of our system. Another type of test we are a bit less acquainted to is the capacity or scale test. Verifying if your system under test can scale up or scale out, or scale down, scale in. That normally entails that you have the capability of using or emulating a big number of traffic flows, for example. What is normally common in industry is the interoperability tests, especially based on specifications. We want to make sure that different components of the system can talk together, interact. Finally, what we normally do as well is a functional test. We simply verify that the system under test performs the actions that it is supposed to be doing. Let me now give you an example of an existing formalized test case that has been defined in 5G-VINNI in deliverable D4.1. This is just an example. There are many test cases included in there. The test case I have selected for this example is the virtual EPC non-standalone network performance measurement. It's a bit of a collection of different types of measurements, and it can be applied in any test phase. The system under test is the virtual EPC as a whole, so it's a service system, and it is an end-to-end test. The test environment in which this test is typically performed is a semi-isolated or non-isolated. That's because it might be difficult to have a full end-to-end test, so an entire EPC allocated in a sandbox. It's common that is sharing at least servers and infrastructure with other components and functions. Which type of test is it? It's obviously a performance test, as the name also precise. A test case is formalized in the following way. It obviously needs a name. In this case, is virtual EPC NSA network performance measurement. You need to describe it with a purpose. So why are we doing this test? And a quick description of what the test is supposed to be doing. You need to define a set of initial conditions to make sure that the starting point of your system is a known state. You can also describe how you want to change parameters. In this case, we do not want to change any parameter or sweep through sets of parameters because it's the entire core network. It would be somehow unrealistic to start tinkering with that during a test. Then we need to define clearly procedures and expected results. The procedure is, for example, verify the IP connectivity, measure the latency, run a specific test methodology from a standard document, and so on. For each of these stages, we are expecting a certain outcome. These outcomes are the ones aligned with the SLA that define if this test is passed or failed. Please remember that this is a test case, so it's an extremely formalized and well-structured way of verifying a system. This is the way in which all your mobile phones and all your network components are tested and verified before they are released on the market. Let's now move to something a little bit higher in level. That is a test campaign. A test campaign, simply, it's a bundle of test cases. Sometimes in certification labs, a test campaign is a part of what is normally called a test plan or a test suite. In Vinny, let's just refer it as test campaign as a bundle of test cases. It obviously maintains the same well-structured nature of the test cases. And besides of the different test cases, it might also contain generic test setups and or test environment setups definitions. Test campaign is a tool we use to simplify the interaction with tasks. But what's mostly more interesting for you is the definition of an experiment. An experiment provides insight into cause and effect. So what we want to do is demonstrating that we have a specific outcome when certain parameters are manipulated. We need to define an experiment in a way that the procedure is always repeatable. A test case defines very rigid procedures with very specific stress inputs and very specific SLAs. An experiment in this sense is much more loose. We want to change parameters. Sometimes we might not even know what we are expecting out of an experiment, and we are just measuring. Nevertheless, it might be, and I strongly suggest to, useful to formalize an experiment, at least with most of the guidelines, as a test case. That should help everybody to consistently have results out of what they are doing. It's also easier later on to perform post-processing and data analysis because we know that we are comparing apples with apples. In order to make easier for you to understand, let me try to give you an example on how you could define experiments. Let's take a use case, an example use case, a PPDR. We have an ambulance that is running in the city, crossing different cells, and between the accident point and the hospital, it's crossing multiple cells. When this happens, we might incur sometimes in a temporary loss of connectivity. Loss that can last from few milliseconds to several seconds. We want to ensure that if this happens, our application is properly capable of coping with this temporary loss of connectivity. Here I give you an example of the application where we have voice, video, and patient vitals transmitted by the ambulance through the network to the hospital. How should I define this experiment and formalize it in a way similar to a test case that can help me keeping track of what I'm doing. Presetting the stage in the first place, but if I modify this experiment while I'm doing it, I also have a template that I can use as a logbook, as a journal to keep track of the changes I'm making to the experiment. Let's then try to define the experiment as a test case. So which test phase are we targeting? Any. What is my system under test? It's a service system. It's the PPDR application. What is the test condition? Obviously end-to-end. And the test environment is either semi-isolated or non-isolated. The type of test I am performing is mostly functional, but I might also want to check certain performance numbers. Let's do a formalization similar to what you have just seen in the test case example. We need a purpose, which is verify the behavior of the app in case of handover. A description, that is a procedure to check this when the vehicle is moving across cells and suffer temporary loss of connectivity. We define certain initial conditions that the app server needs to be available and reachable. The mobile device is connected in a location inside the cell with a good connectivity, like a cell center. The parameters here are just an example, okay? In particular, we want to check what happens when we are changing buffer sizes and we are changing the vehicle speed between 40 to 90 kilometers an hour. Now, while the audio and the video buffer is something that can be automated, the vehicle speed, it's still unfortunately due to human interaction. Nevertheless, it's a good practice, even in these cases, to mark down what we want to do, what we want to achieve. Now, what procedure should I follow to perform this test? The example is relatively simple. First, I need to verify the connectivity with the network and the application server. Then I need to start the audio, video, and patient vitals applications. I need to start driving from a point A to a point B through a route at the speed defining the parameters. Then I need to start measuring, and again, this is just an example, frame rate, reconnection attempts, jitter, whatever you want to measure. Then repeat step 3 in the opposite directions 5 times. So go from A to B, and then B to A, and then A to B, and then B to A again. Then stop everything. Stop everything normally means that we are resetting the system, and then we are repeating step 2 to 6 10 times. We collect all the logs and the measurements, and we upload it to a server. Now, please note that we did not set any expected results. The reason why we are not doing that is that we don't have specific expectations. Of course, if I am checking the connectivity, I want the system to be connected in a good state. But when we start talking about driving, I am expecting the ambulance to drive. If the ambulance is not available for driving, then I cannot even simply perform the test. It should come without saying. And for the frame rate, reconnection attempts, and jitter, I don't have an SLA. Of course, I want it at the best performance possible, but I might not have a very clear and sharp number in mind. I want to first investigate what this clear and sharp number is. Let's now move to the passive observation of the system, and in particular with monitoring as a service. These slides are the ones that have also been used during the onboarding webinar of 5G-VINNI. So please bear with me if I'm saying something you have already heard. Let's define first what monitoring as a service is. It's targeted at having a constant overview of the health and performance of the system. That's its goal. Monitoring as a service is composed of two categories of services. One, it's network monitoring or visibility, and the second one is telemetry. Network monitoring or network visibility is observing the packets that flow through the network. In particular, observing critical points. You don't want to observe the entire network as a whole. It's too much of an overhead. Telemetry instead is collecting metrics, health or performance metrics from each individual network service, VNFs, VM, container that you have running in the network to help you understanding what happens to each of these components. Both these services, these two categories, are offered under the same umbrella of MaaS to make it easier for the user to consume. This is an example, or let's say a possible implementation of network monitoring that will be available in 5G-VINNI in future releases in selected facility sites, which is the presence of virtual taps that can snoop the traffic and the availability of a packet broker to filter, sort it out, and have it re-forwarded to your own tool for performing analysis. Telemetry is maybe a little bit newer and can be implemented in two ways. In particular, it might be interesting for you to prepare your VNFs or your applications in a way that they can either actively push metrics to a database, for example, Prometheus, or have available endpoints that can be queried by what's normally called a scraper that collects all the measurement for you and pushes them into the database. Finally, let's have now an idea of what we have just seen together. First, we have defined the key vocabulary and terms for testing and experimentation. We have defined what are the motivations and examples of test as a service. You should now have an idea on how to define test cases, test campaigns, and experiments through the set of presented examples. Finally, we have defined what monitoring as a service is in 5G-VINNI and how you could start thinking about using it in future releases of the system. Thank you for your attention.